double pendulum is a classic example of chaotic motion in a dynamic system. I've created a SOLIDWORKS assembly with these simple parts, and all I have to do to see the move is create a motion study, add gravity, and SOLIDWORKS Motion will automatically respect the mates and give me a simulation of the physical motion of these parts. As you can see, they move erratically, unpredictably. Another way to look at this would be to start the calculation over, this time applying a trace path in SOLIDWORKS Motion. I'll apply my trace path to the end of the second bar and watch as the program calculates the motion again. The system repeats the same movements, but never quite the same. As we watch the trace path, we see that it never quite goes back over the same line again. Chaotic systems are considered impossible to predict from a practical standpoint because they are so sensitive to their initial conditions, even when we know all the equations that govern their behavior. Examples in the real world include turbulence, formation of cells in biological systems, and even the weather. This is known as the butterfly effect, a term that's been used incorrectly in many popular movies, TV shows, and books. Another way to look at this in SOLIDWORKS, since all the materials are free, would be to create a larger assembly with more than one pendulum, all starting from a slightly different position. Here I've got 10 of them, all on the same axis, and I've got their starting positions offset from each other by 1/10 of a degree. This has already been calculated, and when I play it back at 1/10 speed, what you'll notice is that at first all 10 pendulums seem to move pretty much together in sequence. You can tell very easily which was the first to fall and which was the last. But at about the 2-second mark, which is coming up right about now, all their paths start to diverge, and it becomes impossible to tell which one started first and which one started last. This is chaotic motion. Even without taking into consideration complicating factors like friction, air resistance, vibration, or parts that are less than fully rigid, like they would be in the real world. SOLIDWORKS Motion is a great tool to analyze fundamental motion problems like this and many, many more.